Hey guys, so today you and I are going to talk about crashing and reliability. So let's get into it. So the question in question was, Frederick, as a software engineer, can letting the system crash as long as you have control over it lead you to build a reliable system? Yes. Because it depends on what you mean by crashing the system, but a crash, a system failure, is a guarantee, basically. Just as airplanes or similar sort of anything like that is, there are going to be failures. Components will break. Planes will have issues. And the whole point of an airplane is, well, not the whole point, but one of the, that's why they have such rigorous laws around quality, because when that happens they have to have redundancies or fail-safes or graceful degradation, failing gracefully, as we software developers call it. And software developers, well, we can design systems in the same way, and ideally we should. Because it's the same sort of deal, right? Some websites or applications or whatever we have are actually mission critical, and depending on how critical the systems are, this is what we call high availability. We simply cannot afford that the system goes down. There are systems such as, say, the communications systems for ambulances and responders, like emergency responders and things like that, where they coordinate using our communication systems. That can never go down, ever, for any reason. And the way you fix that is with a lot of money and redundancies and etc. etc. So a reliable system doesn't necessarily mean that it's never going to crash. It just means that the impact of the crash is really not an issue. Something that I think is really cool is that if you look at how Amazon and Google and Microsoft and certain like the cloud providers do virtual machines, and like how they provide you with the computational resources you need on their platforms. So a lot of their server warehouses, or like their server farms, they have a system in place where the actual mechanical components can fail, but the system is actually automatically going to roll over the different, like the computations that are running on the machines will actually find somewhere else to live, and then they can go and replace the mechanical component in a very effective, usually it's a very effective process, where they just switch out in the racks that they have the component that failed, plug in a new component, and then move on, and then like the resources can be funneled to that point. This is sort of for those of you who do A/B testing or feature flagging or similar sorts of things, or canary releases, depending on how you want to define it, this is exactly the sort of pattern that we're talking about, where you can make changes to the system or things can fail or so forth, but it doesn't really matter because you have redundancies in place so that traffic on your site or whatever you're using can be funneled to different places, so that the people using the system are usually none the wiser. And then you can fix the problem and they can continue using it. That's what really, in my opinion at the very least, that's how you create a really quality system. The idea is not for everything to be perfect. There is no way for you to have everything perfect. I mean, even NASA and like the space program, SpaceX and so forth, they have bugs in their code. No matter how well you write, you will always have some type of bug. So it's a really good idea to be able to redeploy software remotely, so that you can update, all the satellites and rovers and whatever you have, right, and fix them in a remote fashion. And so I work on an application like this right now, for example. It's an internal system for like a gigantic corporation, where the idea behind the system is that they're going to host all of their internal systems through this. which, as you can imagine, becomes very quickly the most mission critical system they have, apart from how they sell things and so forth, which because this is their master system, basically, where all of their different agents and salespeople and different administrators are going to use this. They're going to use this system in order to like handle orders and like shipping information and customer information, like all of this sort of stuff, right? And when you build something like that, you have to realize that anything that goes wrong, any breakage whatsoever or downtime, stops the company from making money. And not in, in a sense, it's different from selling things on a website, because if you have an e-commerce platform, if you go down, then you might not make a sale. But in this situation, it's in a sense even, it's not worse, but it's on the same sort of level, because now if something goes down, well, maybe the system goes down when it's time to give out salaries. Maybe the system goes down when you have that all-important business meeting where you have a customer on the line and you're trying to help them, and then the system goes down, and all of a sudden you can't use it anymore, and you lose the customer. The customer is like, there's this gigantic problem because the system was unreliable at that time. And when you design a system like that, it's a very similar sort of situation where you really have to think about the overall architecture and redundancies, where the way that we design it is very simple. We create microservices for different parts of the system, so that individual components, and they of course in themselves have multiple redundancies, where individual components can have a bug or something like that, or they can have they can go down, but it should still just isolate the blast radius. Like, it should just mean that one specific area or one piece of the system might not be reliable at this time, and then you can use feature flagging or other ways of like just saying that, yeah, this is an issue, we're going to work on that thing. But it's so isolated that it doesn't necessarily have a spreading effect across multiple systems, because that is one of the key elements in making a very reliable system that can crash. You have to understand that the more you couple things, the bigger cluster of functionality you have, the more likely you are to have a serious meltdown. You can of course also argue that the more distribution you have in like a large network of services, the more likely you are to have bugs or other sorts of issues. So it's a very complicated problem. But if you design things in a way where parts of something can break, you even further reduce the risk of having like a catastrophic failure. And then similar to an airplane where a component might fail, but you can never get to a point where the entire system goes down so that the plane crashes. Because even if something small breaks, you can at the very least do an emergency landing and like save the situation. And a good computer system works the same way, where ideally things should be able to break and then sort of just continue working without anybody being none the wiser, or you just inform people that, yeah, this part of the system is currently a little bit unstable, or we're looking into it, so you might not be able to use that, but everything else is working. But as long as you never get to a point where, holy shit, the whole thing is down, well, then you still have a reliable system. So what I want you to take away from this is that you can absolutely have a reliable system that crashes, because if you haven't thought about that, almost all the systems that you work with or that you could rely on every single day have crashes. They have outages, not in fairly frequent order. The larger the system, the more stuff that can go wrong, right? So the trick is, when you design your systems, to create a solution where there are redundancies. You might have multiple instances running, or you might split things so that certain pieces can fail in isolation, and so forth and so forth. There are many ways to make a system fault tolerant, but you can never make a perfect system that never ever crashes. And so that's what I like about the cloud providers, where they sort of embrace that hardware is going to fail at some point. You don't try to buy expensive stuff that never fails. It's actually better for you to create a solution where recovering from an error is almost seamless. And when you do that, you can actually have a working system from the perspective of everybody who's using it, even though the system failed. That's what's so powerful about it. It's a system that it's almost a self-healing system, where you never get to that point where things are so bad that it's unusable, but individual things can fail behind the scenes, and then they recover without you even knowing that they failed. That's a very good system. Have a great day.